everyone. It's my great pleasure to introduce Michal Paradowski, a professor in applied linguistics at the University of Warsaw. Today, Michal will focus on network analysis. He's an expert in network analysis in the field of psychology and language learning and teaching. He has been using network analysis in his research for the last 14 years. And as one of the research methods SIG co-coordinators, I'm very honored to have Professor Michael Paradowski here with us. So, Michal, the floor is yours. Thank you.
All right, thank you so much, Giuseppe, for this invitation and welcome to everyone. So, networks. If you think about how the world is perceived and analyzed, then we can talk a bit of a turn in approaches in the last decades, away from a perspective that would focus on individual variables and as largely independent entities, where you'd investigate means, variances, and of course, the relationships between them, but you'd focus on those variables as largely independent. You could think of them as attribute data, towards a perspective that would prioritize the relationships and the interdependencies between the elements, and focus more on the structure of complexes, whether complexes of persons, groups, or complexes of personality traits and other psychological constructs. So in network approaches, the assumption is there is interdependence between the different blocks of interest, and we're interested in relations such as friendships, if we're talking about agents as persons, or partial correlations if we think about psychological variables. And the network perspectives came into the field sort of together with dynamic systems and complexity theory, which both look at the relationships between variables and the dynamic nature of systems. So network analysis allows us to capture those complex and dynamic relational structures, for instance, social realities. You could think of classroom interactions, or if we are more interested in psychological variables, then you could think of, for instance, learner behaviors and emotions. Relations and dynamics that would not necessarily be easily captured in traditional statistical methods. So network analysis, in order to do that, uses graph theory to map and model the entities which are seen as nodes, and then the relations between them that are seen as edges. And as the title suggested, today I will be focusing on two subtypes of network analysis. One, social network analysis, and then we'll move on to psychological networks. So social network analysis, often abbreviated as SNA, tries to analyze and visualize interactions and relationships between either individuals, single students, teachers, and other interactants, learners, or groups, organizations, and similar entities. So the method allows us to evaluate social structures and then influence within those networks and centrality, that is the position of each agent in the network. And the underlying assumption is that our behavior is not just an outcome of our individual agency, but that it can be influenced by that of our peers, and by our peers' influence sort of and position in the network itself. So the primary unit of analysis is relational data, starting with dyadic data, so when you have two agents and how they interact with one another, and then you sort of put all those interactions together. In social network analysis, you can easily distinguish two major types of approaches or networks. One is egocentric networks. That is when you ask a focal individual that you're interested in to tell you who they interacted with, but you only have that person's perspective. So that person is known as ego, and then we know their report on the interactions, communication, friendships with others. But that's all the information we have. We don't have information from those partners that they nominated. So the alternative that allows us to have a more complete picture of the situation is what is called a sociocentric network, where you have information not just from the ego, but also from their interlocutors. So you can verify that information and you have multiple perspectives. And in that way, if you, for instance, look at a class group and you interview or you give a questionnaire to each member of that classroom, then you can get a picture of the interactions within that classroom that come from all the participants. So within social network analysis, the nodes are social actors or agents. So we could think in our context of interest learners, teachers, there may be native speakers that learners interact with. And the edges are the social ties that connect them. They can take different forms. So typically in the context of language learning and teaching, we can think of communication, who talks to whom. But it could also be collaboration in terms of group projects, advice, or different kinds of relationships such as friendship, partnership in, for instance, a school project, situationship, and other romantic relationships. The data structure that allows us to, or is the first step to building the network, is an adjacency matrix that tells us who is connected with whom, and sometimes to what degree or to what extent. So the research questions that are typically answered using social network analysis look at social capital, because the position in the network and who you're connected with are seen as markers of social capital, and information flow in some research questions. So we could think of questions, for instance, how are an individual's learning outcomes affected by their position in the social structure? For instance, whether they are central or whether they are on the periphery. How do interaction patterns, so not just position, but also what goes on in the network, affect gains in language proficiency? We could also investigate how network structure changes over time, from time 1 to time 2 to time 3, and so forth. There are two levels at which network data can be operationalized and analyzed and counted. The first is network level data, where you look just at the sort of take a bird's eye view of the network. So you can look at the size of the network, that is how many participants there are, at the diameter, that is if you map the network and you look at every possible pair in the network and the shortest path of, for instance, connection between the two agents, then the diameter is the longest short path in that network. You can also look at density. Density basically tells you how many of the possible connections in the network are realized. So for instance, if you only have three participants, then you can have three connections. You can imagine it as a triangle, right? If all those three connections are realized, that is, person A knows person B and person C, and person B knows person A and person C, and person C knows person A and person B, then this is, a completely dense network because all those connections are there. But it may be that, for instance, one of those persons doesn't necessarily know another one, but only one of the three, right? And then it won't be a fully dense or complete. You can also look at clustering coefficient, that is whether there are subparts in the group that are sort of isolated and only connected to the rest by weak links. And then these can be often detected with unsupervised machine learning algorithms that perform the role of community or cluster detection. The three that are there are the ones that are used most often. Louvain is one of the most frequent ones. I personally prefer OSLOM because OSLOM can do away with some of the shortcomings of the other two approaches, and it also gives you the statistical significance of the outcome. Within social networks, we often observe the phenomenon of homophily. Birds of a feather flock together. That is, individuals who are somehow similar tending to stick to one another. This may take the form of gender homophily, for instance, male participants hanging out with other male participants, female participants hanging out with female participants. This may also take the form of what is often called the rich club phenomenon, where the more influential participants will again stick together, for instance, high achievers. And then the sort of view of the network is often referred to as network topology. That is, you could imagine it as the geography of the network. So that's if you look at the network from a bird's eye view. What is usually interesting from the perspective of classroom intervention is node level or individual matrices, and those are centrality matrices because they tell you how important, influential, central or isolated a person is within the network. So now you start to zoom in, and that allows us to then investigate how the position in the network may be affected by other factors and may in itself influence other factors. So well-connected students could be seen as influencers or sometimes as information hubs. The most frequently mentioned centrality metrics, there are a few dozen thereof. Here I'm just showcasing those that are most frequent, especially in studies of second language acquisition. Degree, that is how many other contacts you have, that's the easiest metric, really. So you just look at the number of friends, interlocutors that a person has mentioned. If a network is directed, that is, you're not just interested in reciprocal communication, but you want to distinguish, for instance, talking to others versus others talking to you, then that's going to be a directed network because you have the direction of the interaction. And then you can distinguish in degree and out degree. In degree will be how many persons talk to you. Out degree will be how many persons you talk to. Then we can also look at betweenness, and I will be illustrating them with some examples later on. Betweenness tells you how many other persons there are, the minimum number of other persons that you have to reach in order to get information, for instance, to another participant. So let's say that you don't maybe know that other participant directly. So you have to pass the information to someone who may know that participant, and maybe they know them, so they will convey the information further, or maybe they don't, so they will still have to pass the information on until it reaches the other participant. So if someone is in a position in the network where information passes through that person on quite a lot of paths, then you could say that they act as a bridge. Right? They are necessary in order for the information to reach the other parts of the network. Closeness centrality tells you generally how close you are to the others, and this is easily visible in visualizations of social networks, because those nodes that are close are typically really in the visualization located adjacent to the others. And a slightly more advanced way of looking at importance is when you're not just interested how many people you can reach or contact, but also how important those people are. And here you look at such measures as eigenvector, PageRank, VoteRank. PageRank may be familiar to some of you, especially if you remember the earlier times of the internet, because that was the algorithm that Google used in order to position the results of the websites in its search engine. The name actually comes from Larry Page, who introduced that algorithm, but the simple idea was that you're going to see a page higher up in the results if that page is linked to by other important pages, so other pages that also a lot of other pages link to. Right? So it's not just that quantity matters, but also the quality of the connections becomes important. So here you can see four again of the same matrix, and they are illustrated on one and the same network. This is a network that if you start reading about social networks, you're probably bound to come across it sooner or later. It's like a textbook example. It's called the Zachary Karate Club. And actually, if you go to Complex Networks conferences, then there is an itinerant prize, basically a statue, that goes to the first person who mentions Zachary's Karate Club in the event. And I've actually seen that passed on in one summer school, Complex Systems. So this was a karate club that basically split after a schism due to a conflict between two instructors, and the two instructors are the two central nodes that you can see in the first and the second diagram clearly, and the last one. So in each case it's the same network, but the centrality in each of the four diagrams is calculated differently according to basically what you're interested in. So whether you're interested in the number of others that are connected to you, or whether you're looking at the number of times that information has to pass through you in order to reach other parts of the network, or the closeness or the importance of the others, that is how well connected the others are. And you can see that, okay, the location of the nodes is the same, but the size of the nodes, which in this case indicates importance, that size changes depending on what you count. So how can we apply social network analysis to explore classroom dynamics, whether online or offline? What kind of research questions can we ask, and what kind of real-world problems can we answer? Well, SNA allows us to investigate how learner networks form and how they impact learning outcomes. So, for instance, you could look at communication patterns and language contacts. Frequent contexts here are study abroad, because that's a situation when you're taken out of your primary community, you're parachuted into a new place, and you have to establish new social ties, and most of the people there have to do the same. So it's so many of the people that you know are actually from your studies or from your class. This can help understand language practice opportunities, that is, who has the opportunity to use the target language with whom, and other languages with whom. You can also look at how leaders emerge in such networks, and how support is offered either by peers who are from your country or peers who are from other countries, or instructors or native speakers on the spot. We can use social network analysis to look at information flow and collaboration. This is also a method that's often used to investigate virtual learning communities and online platforms, because you can scrape the data and then you can look at who commented, for instance, on whose posts and who talked to whom. And using the algorithm, we can identify learners who are central and those who are on the periphery. And then those who are central will typically be seen as more influential. There may also be an analysis that goes beyond learners and investigates which teachers are maybe more influential than others. That can help identify points for intervention. For instance, if there are learners who are isolated on the periphery, and if you detect that early enough, then you can, as the instructor or as the studies director, you can take measures to promote inclusion, for instance, by pairing them with others or by changing the composition of the groups. Such approaches also allow us to monitor classroom dynamics over time to see whether perhaps something undesirable happens. And the network insights from the network can help leverage, for instance, peer tutoring. That is, all right, whom should we pair and who is doing well enough? If we look at the methodology and things to consider, take into account and remember, then first we start with data collection. The most often used here are self-report questionnaires. For instance, sociometric surveys that are based on the list of the participants. There can, instead of paper and pencil or online questionnaires, you can also ask the participants to keep logs or to use apps such as experience sampling method, for instance, the LangSnap app, where they will indicate every now and then who they talk to who they talk to, how often, using what languages, and so on. What is important in social network analysis is that, unlike other questionnaires, here what is important is high response rates. So let's say you've got a group of 25 students. You want as many of those students to participate, because if there are too many missing data points, then you've basically got a lot of gaps in your network. So less important than what is your sample size overall is, if you have a few groups, that those groups be as complete as possible. So if you've got more groups and some are less complete, then you may decide to discard them and just focus on those where you have high completion rates. And obviously, because we're dealing with human participants and their social interactions with others, this is where we need informed consent forms and we need ethics clearance from institutional review boards. Other possibilities that can help reconstruct social networks are classroom observations, typically not by the teacher themselves because they are usually busy teaching, but by a researcher, or a video recording of the interactions and then investigating who talked to whom. If the interactions take place online, for instance on a learning management system, a forum, Web 2.0 sites such as social media, then that's much easier because you just scrape the data. Sometimes it's better to have actually access to the data from the platform than just to rely on API interfaces, because they are not always they won't always give complete responses, but that's another approach. And yet another one, but used on short time scales, is sensors, such as, for instance, RFID devices. Those typically take the form of badges that will record your location and can also record if you're standing in front of or sort of facing someone else. And then if you're standing and facing them for a longer time, then probably you're talking to each other, because otherwise that would be a bit awkward. Those are used at shorter time scales. So, for instance, events that map the movement of visitors to a museum, or movements of patients within a hospital, and patients and doctors. Those can be slightly longer time scales, but you've got a closed environment where there's little exchange with people from outside. All right, so once you've got your data collected, then typically you start with a visualization of the network. There are many ways of either visualizing or modeling a network. You can also try to build models that predict the resultant network and then compare them with your network and see how much your model can actually behave to give you the same outcome as in real life. There are also temporal networks, that is ones where you take several snapshots of the network and you can see dynamic changes. And the networks can also be multi-layered if you're looking at different types of relationships at the same time. So let's see a few practical applications of social network analysis to language learning. This was a study published in the Modern Language Journal, where we looked at a complete cohort of Erasmus exchange students in Germany that were taking part in an intensive German language program prior to the commencement of their studies. So you can see the participants here. Here you can see the network of communication. The color represents the first language of the participants. The size of the node represents progress, so you can see that there are three different sizes. And then you can see the links, so who communicated with whom. Some findings that we got from that project was that closeness centrality negatively correlated with improvement. And the take-home message here would be that it's better to have few but high-quality interactions with others than several interactants, but where you're basically just having superficial interactions. What is also possible, as I mentioned, is cluster detection or community detection, and here you can see this in this hive plot. So this is a different way of visualizing that same network. You can see three branches in this hive plot. The one in the top left corner shows you that most of the nodes are red. Those are native speakers of English, primarily Americans. And you can see that that branch is significantly underperforming. So the 4 students who made the least progress, they are native English speakers, they are on that branch. And then most of the other speakers on that branch made medium progress, and there's only one that really made sort of substantial progress, right? Then you can see another branch in the bottom left, centered around speakers of Portuguese. And the third one that's to the right hand side that doesn't have such a common denominator. And there's also one participant that is largely isolated when you filter out the weakest connections. Also, in this study, we looked at communication among the students across the 3 groups of proficiency, and we can see that out of class, they tended to interact with participants who were at different levels, so they didn't, when they would leave their language classroom, they would basically speak to others, not those that they had, in class. And two more findings were that what was more important for progress than total talking time in German was the proportion of talking time in the target language. And also that, three actually findings. Another one that might be counterintuitive is that if more people talk to you, then you actually made less progress. Maybe counterintuitive because you would expect you're getting more input. But what happens here is probably that, all right, other students talk to you in German. They're practicing their German. They're testing out their hypothesis. They're producing output. You're just a passive recipient. And as a passive recipient, you can understand a lot without necessarily parsing all the syntax. So what is more important here seems to be the output hypothesis as hypothesized by Meryl Swain, for instance. And we also found a very negative influence of hanging out with people who shared your first language, even if you claim that you used other languages and not just your mother tongue with them. All right, so this is one example of what we can do. I'll be showing a few QR codes if anyone's interested in reading up more on the methods and the findings. And then on the last two slides, I will show some references for some of those studies, not all of those studies. All right, we can also look at marginalization. I said that network analysis can serve interventions. And this is a project that we carried out among Ukrainian refugees that were enrolled in an intensive course of the Polish language in another university in Poland. Here you can see the questionnaire that we've been using in most of those studies. This one is in Ukrainian, but I'm going to quickly explain what goes on. So on the left-hand side in that column, you can see the names of your participants. Here it's only the middle names for previous reasons, but as the student, you'd see all the names of your classmates. And then you can indicate whether you were the initiator of the interactions or that other person, if you talk to one another, how much you talk to the other person. Here it's important that the scale starts at 0, unlike other Likert scales, because that is a way to indicate that you didn't talk to that person at all. And you can also indicate the proportions of the languages that you used. In this project, we had over 250 participants in 3 different courses coming from all over Ukraine. One of our research questions was whether dominance in Ukrainian or dominance in Russian would affect progress. And here, incidentally, you can also see how networks can be used to visualize distances. So here, the larger the distance between the nodes here are languages. So in the top, well, sort of top right or middle right, that's Ukrainian. The bottom right, that's Russian. And then at the top center, it's Polish. So you can see that Ukrainian is closer to Polish in Tishchenko's reference book than it is to Russian. Right? So because there are those differences, and Russian is further away from Polish than Ukrainian. So because of those differences, we were interested to see whether dominance in one of the other 2 languages would affect progress. It did not, but we found a different relationship. That is, those students who were dominant in Ukrainian were very often in the center of the group. Here you can see those nodes in yellow. Whereas those who were dominant in Russian were often on the group periphery. Here those are the nodes in red. And remember that these networks are reconstructed from the reports of all the participants. So it's not just that one student felt isolated. This comes from the reconstruction of the full network, right? So here you can see how we can use network analysis to detect such potential isolation or marginalization, and then maybe reorganize the classroom so that those students are more integrated. And we could also see in that study that our degree correlated with perception of integration, the interaction with classmates, and generally speaking, Ukrainian, not Russian, right, to classmates and strangers. This study was recently accepted. It already has the DOI, and we sent the proofs back in September. We expect the journal to come out in December. This is a journal on immigration and integration. I mentioned that social networks can also be looked at longitudinally. So let's see two examples here. This is a group of American students from a university in the United States taking part in a 3-month intensive language program in Amman. This is in collaboration with colleagues from Wrocław and the US. 41 learners, the entire cohort, and the location of their sojourn. So let's look at how the network changes over time. We see that the network is relatively stable, but what happens is what we termed homophily, gender homophily. That is, male students tend to hang out with male students and female students with female students. Let me walk you through this diagram because it encodes quite a lot of data. Each node is a student. The size of the node indicates progress over time. The shape of the node indicates gender, so the circles are female participants, the octagons are male participants. The color of the edge of the node indicates shared accommodation, shared house, not shared apartment. And then the hue inside the node indicates starting proficiency. So if it's white, then it was like pretty low proficiency. If it's dark olive green, then it was pretty high proficiency. And here we are only visualizing the top 5 interactions, because otherwise the network would be so dense that it would not be legible. So you can see that the octagons tend to talk to octagons, so males to males, the circles with circles, so females with females. The 4 ellipses in dashed line, those indicate 2 married couples and 2 that were dating. So you can see that, for instance, 19 and 29, they are married. You can see that they don't really talk to each other much. Now, after that was the first month. In the second month, it looks similar. The positioning changes a little because the algorithm tries to make the network transparent. And in the third month, it's also like very similar. That is, it's more or less the same people interacting with one another. So pretty stable in this case. We were able to investigate the impact of centrality metrics on progress and some other variables. So, for instance, we find that those who had high betweenness centrality were more realistic in the assessment of their proficiency relative to the others. So they were probably exposed to, so they could know what the others sound like in Arabic, so here they could calibrate themselves better. Betweenness also correlated with self-perceived improvement in reading. That could be surprising, but actually the reading exercises were often solved in groups, so you would interact with others. Whereas another centrality measure negatively correlated with progress in writing. This is not surprising because writing is an individual activity. If you're engaging in writing, then you're not communicating with others. And most of the time, you're not going abroad really to learn writing anyway. There are a few other findings that, again, looking at centrality metrics and others, I'm going to gloss over them because that is also a published study, came out last year, and you can read up on it a bit later in the interest of time. You can also see that 2 two of the four factors that influence objective progress are actually to do with social interaction, so it does play a role. And we also find that the centrality metrics tend to drop over time. This is very frequent in a lot of studies of study abroad second language acquisition, where you start out with a larger sparse network and then you trim the ties that you don't spend much time with. And this is the link to that project with a longitudinal analysis. Now, one more example here where we can look at what is called the rich club phenomenon. So we repeated that study with another cohort of Arabic students, or students that were enrolled in this intensive Arabic program. This cohort was slightly smaller, 30 participants. And what we can see here is that the strong leaders are those that have a red circle around them. So at the top, number 19, the top left, 27 and 16, the bottom, 20 and 13, and sort of bottom right, 25. Those were strong leaders. And then this was the first month of the sojourn. And if you look at the second month and the third month, then you will start to see that those strong leaders started getting together, especially 13, 19, and 20. They start to stick together, right? And then 25 is also like very close there. So you see this emergence of the rich club phenomenon. Importantly, the leaders, some of the leaders are central, some of the leaders are on the periphery, so the position in the network sort of globally doesn't matter as much as, you know, some other behaviors. I mentioned that betweenness can matter in information flow, and this was a study that we carried out in 2011-2012, looking at the social diffusion of linguistic innovation in a microblogging site such as Twitter, but a Polish version thereof. Here, what you can see there immediately is, or you can investigate easily, is the popularity of the different users, and you can see that it scales like a power law. Here you can see the giant component, and you can investigate how neologisms spread and in that self-contained system. Here we used Valente's idea of threshold exposure. That is the idea that each of us has a different resistance to outside influence, and we need a different number of other people, or a different proportion of other people, to exhibit a behavior in order to engage in that behavior ourselves. So let's make this more tangible. Here we see two individuals. For one of them, it's the one on the left, it's enough if 60% of their contacts engaging in an activity to do the same. The guy on the right-hand side requires a slightly higher percentage of examples in their environment. So right, and the four circles are, you know, people who are engaging in an activity at the moment. So for the guy on the left, one of their 5 contacts are doing something, that's not enough. 2 out of 5, that's not enough. 3 out of 5, okay, that's their threshold. So then they decide, all right, it's worth doing that. So they start engaging in that activity. And now that starts to meet the threshold for the person on the right, who will then engage in that activity as well. So the behavior can spread. So in this study, we looked at the creativity or innovativeness of internet users. We found that it scaled like a hand-shaped unimodal. We looked at the threshold at which new words or expressions were adopted. We found that the threshold was pretty low, unlike in real life when you can lose more, because this is not a very high-stakes scenario, you know, using a new word or expression. Engaging in a new activity may be high stakes. And we also found that the most popular expressions were adopted at moments when already a lot of our friends were using them. And that's probably not because everyone was waiting for others to use those expressions, but because people typically are not on social media 24/7. So if there's a popular expression, it may start spreading, but you're, for instance, doing other things or you're asleep. And then you log onto the platform, and then you're seeing that expression everywhere, so you're starting using it, but you're not starting using it now because you were waiting. You're starting to use it now because you are late to the game, so to say. And then a reference for that one. All right, the other kind of network analysis is psychological network analysis, which allows us to look at the complexity of psychological and other variables in the student's or teacher's mind. And this followed a shift away from fixed latent traits to dynamic systems that you can intervene upon. And the constructs were reconceptualized as phenomena that emerge from the interactions of the different elements and are affected by those other elements and the interactions. There is no one single cause assumed, so no single directionality. And the focus is on revealing the relationships or interplay between the variables, affective, cognitive, attitudinal, behavioral, where it's believed that the patterns of the connections will reveal the structure and dynamics of the system. So the focus is on understanding interconnected constructs, emotions, beliefs, attitudes, and to capture the dynamic nature of behavior, such as language learning, for instance, and the factors that affect that. So unlike in social network analysis, here the nodes are variables, constructs, behaviors, skills. They may be items or they may be full scales. And I'll be showing examples of both. And these are seen not as latent causes, but as active components of the system. The edges are dependencies, conditional dependencies, because as in social network analysis, they take into account the impact of the other nodes. These show where influence happens. And the edge weight can be seen as the strength or magnitude of the relationships. The strength of the node basically sums the absolute edge weights. Absolute because sometimes the impact may be negative. And if you added positive and negative, then you decide, well, there's no impact at all. That doesn't, of course, happen. So that's why you take absolute weights. So where central nodes will be seen as the key drivers in that complex. The bridges, you can find constructs that are sort of bridging others, so you could think of them as mediators. And the data structure from which you start off will typically be a correlation matrix. If there are clusters, then you could see that, okay, those symptoms sort of go together. So, for instance, research questions are typically about the dynamic systems and the co-occurrence in the system. For instance, how do different constructs interact, for instance, in the learning process. Methodologically, Gaussian graphical models are typically used in order not to have an oversaturated network where you won't see the wood for the trees. You use reduction techniques such as lasso that basically shrink the weakest connections. And if you want to compare two networks, either between different populations, different conditions, or over time, then you can use a network comparison test. Again, there are a few measures that can be used, such as centrality measures. As before, very similar kinds of interpretations. Again, you can detect subcommunities or clusters. And additionally, typically what you look at in network analysis or what you report is the stability of the network, usually using both bootstrapping, confidence intervals for that, and stability. So how can we apply it? Well, we use psychological network analysis to take a more holistic view on the psychological profiles of participants. They allow us to identify the most central or influential variables, as well as those that may be sort of connecting or interacting or bridging clusters. And such a view can help us understand the cascades or of influence, intervention, or different impacts, to understand the dynamics of different systems over time, and also identify key points for intervention. So if a point is a construct is influential and another is peripheral, then you typically want to target the influential one if you want to change a system that, for instance, results in negative outcomes. So let's look at a few examples. One of the recent ones where we look at, we can see item level networks is by Lani Freeborn and colleagues, where they used an existing data set to look at the constructs in the L2 self system by Zoltan Dolnier, and which of the constructs sort of go together. That's a 2023 paper in Studies in Second Language Acquisition. We used item level analysis to visualize the relationships and inspect the relationships in a multi-country study of emergency remote instruction. This was also a team project, nearly 9,000 participants, 118 countries, and the questionnaire involved almost over 400 items. Here you can see the locations of the participants, sample constructs. So if we have so many constructs, then if you look at the correlation matrix, then it is not really super legible. Even if you zoom in, or even if you try to look at the dendrogram, it's not super helpful. So enter network analysis. Now we have the same information, but organized as a network, and we already see clusters. And then this is the network of the traits, behaviors, factors affecting teachers. And we can easily detect in the top left corner a few, we could call it the giant component, because that's sort of clustered together, 4 types of aspects: self-regulation, engagement, openness, positive orientation, social skills and contacts. And these have a positive valence. And then on the right hand side we have the periphery, family relationships, future expectations, family relationships and work-home synergy, future expectations, and remote teaching related attitudes and experiences. They have a negative valence. Right? A lot more legible than that correlation matrix that we saw earlier. What we can also detect here, incidentally, is that parts of items that would normally go under leadership and self-regulation are now seen under social skills and contacts, which could indicate that constructs that we were taking for granted as going intact in regular day-to-day life start to function differently during special situations such as a pandemic. And we could also do the same, with language learners, and also detect communities of or clusters of aspects going together a lot more easily than with correlations. And then if you look at constructs as the nodes, then this is a 2024 paper from a project by Magda, where the investigation looked at the predictors of grid and flow, L2 grid and flow in online versus face-to-face learners. Again, a multi-country study. And here you can see the visualization of the relationship between the constructs. And again, you can see which ones are sort of closer together and which ones seem to be the most influential. In this case, L2 grid and two components of readiness for online learning, that is self-directed learning and online learning motivation. And if you add flow into the picture, you can compare the online learning condition versus the face-to-face learning condition, and you can see some similarities, but you can also detect some slight differences, which maybe would not be so immediately obvious with other statistical methods. So that is that paper. So the last few slides, what tools can we use in network analysis? Most of them are computational methods, so you can use R packages. In the case of social network analysis, we usually use iGraph, but then there are others such as SNA or CNI is well known as well, StatNet. And for psychological networks, BootNet, QGraph, MGM, network tools, BGGM. BootNet is typically for network stability and bootstrapping and confidence intervals. Python, which we also used, usually relies on network X. R has a few more packages than Python, but it depends which environment you're more familiar with. C++ can also be used to analyze networks, especially social networks. And then there are dedicated software solutions such as UCNet, Pajek, or Gephi, and Cytoscape. In terms of psychological networks, you can also use JASP. It has that functionality. And for network comparisons, there's also a dedicated app. All right, so the take home from this presentation. Network analysis can be a powerful tool to understand complexity and dynamics in contexts such as education and others, and give new avenues for theory development and for targeted intervention. The focus shifts from variables to systems. The networks allow us to visualize relations and interdependencies and dynamics between peers or psychological constructs. It can identify central actors or constructs that are important in the system. These network properties can be connected then with learning outcomes or teacher well-being and other constructs. And this is something that you will typically be coming across quite a lot if you engage in CDST and similar approaches and philosophies. So here are a few references on the application of social network analysis in intensive language programs such as Study Abroad or Erasmus exchange programs, or courses for refugees or intensive language programs. And here are two out of quite a few examples of psychological network analysis applied to language learner psychology. So thanks a lot, and if we have time for Q&A, then I'll be happy to address any questions, comments. Thank you.
Thank you. Thank you so much, Mikhail. That has been fantastic talk and very insightful and very clear. And thank you also for giving us so many examples on how to apply network analysis. So that was very, very important for all of us. So we have maybe time for one or two questions, because I'm aware that some of us will go to the iApple roundtable soon. So if anyone would like to ask a question to Mikhail. So please unmute yourself if you want to ask a question, or you can even write it on the chat.
It may also be that it was so dense that it was a bit overwhelming.
Well, it was very clear. I found very important to, have an idea of which studies and which context you utilize these methods. So that was very, very important. So how did you experiment this type of methodology in your very first studies 14 years ago? So what?
Right, so this was a bit serendipitous because during the last year of my PhD, as I was walking across the campus of our university and passing the old building of the university library that is now used for classrooms, and then I saw a poster, workshop on language simulations. And I was surprised not to know anything about that because typically linguistic events taking place in Warsaw would be somehow advertised in our institute. So I walked in and walked up to the organizers, introduced myself, asked if I could take part. They said yes. So I did, and it turned out to be an event organized by physicists and attended by physicists. I was the only non-physicist there. But I understood I didn't necessarily understand, the partial differential equations, but I understood the philosophy behind most of the presentations, and then I started wondering, all right, why is it that there are physicists working with these toy models, whereas we can actually obtain and supply actual data and use those methods. So following that, I attended a few complexity science schools organized by different physics and mathematics institutes, and then the European Conference on Complex Systems, conferences on complex networks, and then the first small grant project that I got was for the investigation of the social diffusion of linguistic innovation. And then there was a bigger project investigating the impact of peer interactions in social networks on second language acquisition. So it was sort of by accident that I found out about the methodology from physicists, and then just had ideas how to apply it, and managed to learn enough in order to for it to come to fruition. These are all team projects, so it's not necessarily myself that is doing necessarily the most important or the major part or behind the scenes, but I've been learning. So for instance, in the paper on psychological network analysis, that's actually the credit there goes to Magda, who did the calculations there. But yeah, sort of I'm trying to catch up.
Excellent. Thank you. Thank you. Great. Do we have one more question? Yeah, Pete. Oh, let me read it. Unfortunately, I can't read it. Let me close this. Okay. So what are the weaknesses of SNA, PNA? What methodological problems might a researcher encounter when using this analysis?
All right, so one, especially with SNA, with PNA, that's less of an issue, but with SNA is the requirement that your groups be maximally complete, especially if you take the whole network approach, because if you take an egocentric network approach, then that's less of a problem, but then you can't really use centrality metrics, for instance. That is not possible or not really reliable there. But in a whole network approach, you want to have high completion rates, because it's not that, all right, I have one questionnaire fewer, so I have one data, sort of, like, not true, but yeah, one data point fewer, but it affects the responses of all the others. If they indicated that person talking to that person, but then you don't have information from that person, then you've got like loose strings there. You don't want that. On a methodological level, that is one of the obstacles. And then, of course, you rely a lot on self reports in terms of the interactions, but this is a weakness of most psychological research, unless you have objective measures of communication, interaction. So this I wouldn't worry too much about. In psychological network analysis, I'd say that this type of approach doesn't normally assume directionality, right, between the nodes, unlike traditional approaches from the regression or SEM families that assume paths, right? So here, all right, you can see that these two constructs go together and there's a strong positive or negative influence there, but then you've got to use your theory or a different model in order to, if you assume that this is a directional relationship, right? So that would be, for instance, one difference. I'd say that these are the main things to remember. Another one, in terms of especially social network analysis, is that sometimes it may be hard to give a straightforward interpretation for some of the centrality metrics. For instance, betweenness makes sense if you analyze processes such as information flow or the diffusion of innovation, etc. It may be a bit harder to interpret when you look at language learning, because, well, like, okay, what passes through a student, that doesn't make a lot of sense, right? So those are the things to remember and to omit maybe sometimes the temptation. If you find a relationship between a centrality metric and an outcome, but you cannot provide a logical interpretation, then maybe it's spurious, right? And maybe it doesn't really make sense, including and writing about it, if we cannot explain what goes on behind the scenes. Yeah. I think those would be like the things that come to my mind at the top of my head. There may be others, but I'd have to give it a bit more thought at this time point.
Thank you, Mikhail, for such an insightful uh, talk, and also for your very clear answers to the questions that we have asked today. Unfortunately, it's already time to go. Mikhail also needs to go to present at one of the roundtables organized by the IAPL. But again, I would like to thank you for your time, for your insights, and for also all your suggestions that you have given us today. Thank you, Mikhail, again.
Right, thank you, Giuseppe. And just to add on, because I see Pete's asking about sample size sensitivity, of course, if you start looking at the relationships, then the effect size are going to be dependent on the sample size, yes.
Fantastic. Thank you, and thank you everyone for attending this event. Thank you.
Thank you for having me.
Thank you. Bye.
Bye.